And welcome to Technology Tap. I'm Professor J. Rod. In this episode, managing Windows and thinking like a tech. Let's tap in. And welcome to Technology Tap. I'm Professor J. Rod. For those of you who don't know me, I'm a professor of cybersecurity, and I love to help my students pass their CompTIA, A+, Network Plus, and Security Plus exams. And every now and then I like to throw in a little history of modern technology on this podcast. If you want to follow me, I'm all over social media at TikTok at Professor J. Rod, on YouTube as Technology Tap, on Instagram at Professor J. Rod, Facebook as Technology Tap Podcast. And if you want to buy me a coffee, because everybody who knows me knows that I love coffee, but nowadays I'm taking it with less sugar. It's one of my New Year's resolutions. You can buy me a coffee.com/Professor J. Rod. All right. Before we touch any tool, I need to clear something up. Windows doesn't randomly break. I know people say that. I know students believe that, but that's not true. What actually happens is this. Windows follows rules perfectly, and humans don't realize which rule they violated. When someone says, my computer just stopped working, what they really mean is, something's changed and I didn't notice. And the job of a technician is not magic. It's reconstruction. You are reconstructing the chain of events that led to the failure. That's it. No guessing game, no panic, no reinstallation or reinstalling Windows like it's holy water. You slow down. You ask better questions and you let Windows tell you the truth. Let me give you the most realistic scenario possible. A user said, ever since yesterday, my computer has been acting weird. Not broken, not dead, just weird. This is where bad technicians panic. Good technicians immediately ask, what changed? What updated? What was plugged in? What was installed? What account are you logged in as? Because Windows behavior does not change without cause. Ever. Now let's talk about Device Manager. But properly, not like a textbook. Device Manager is not a place to update drivers. That's what beginners think. Device Manager is Windows hardware negotiation table. Every piece of hardware in your system is constantly having a conversation with the OS. What are you? What drivers control you? What resources do you need? Are you responding on time? When that conversation fails, Windows flags it. That yellow triangle, that's not an error. That's a confession. Windows is saying, I tried to talk to this device and something didn't go as expected. Now here's the part where students always get wrong. They rush to update the driver. A technician doesn't do that first. Why? Because updating a driver changes variables. The first rule of troubleshooting is reduce variables before introducing new ones. So what do you do instead? You disable the device. Disabling a device answers one of the most powerful questions in troubleshooting. If I remove this component from the system, does the behavior help? Does it stop the problem? Does it hurt the problem? If the system stabilizes when the device is disabled, congratulations. You didn't guess. You proved causation. This happens constantly. A system freezes randomly. Mouse lags, keyboard input stutters. Everyone blames RAM or CPU or Windows itself. But Device Manager shows a USB controller resetting, a driver throwing intermittent errors, a device disconnecting and reconnecting. Disable the device, system becomes stable. Why? Because Windows was constantly renumerating the device. Every reconnect interrupts system's resources. That's not obvious unless you know where to look. That's a technical knowledge, not trivia. Now let's talk about disk management. And I need to say this clearly. Disk management is not dangerous because it's complex. It's dangerous because it looks simple. Right click, create volume, format, and boom, data gone forever. Disk management operates under one assumption, that you understand disk architecture. When you initialize a disk, you're not starting it up. You are defining how the OS will interpret every sector on that drive. MBR versus GPT is an exam fluff. MBR is older, it's limited partitions, and has a legacy boot system. GPT is modern, supports large disk, and it's a UEFI system. If you choose wrong, Windows doesn't warn you later, it just behaves strangely. Students think Windows is broken when they can't extend the volume. It's not broken, it's geometric. Disk management cannot magically move space. Unallocated space must be adjacent, not somewhere on the disk, not technically free, adjacent. If the layout is wrong, the option is grayed out. Windows is saying, I physically cannot do what you're asking. And instead of fighting the OS, technicians learn to read layouts. Let me say something controversial. Most Windows bugs are permission problems. A user said, it worked yesterday. That doesn't mean the system changed. It might mean they logged into a different account, group membership change, UAC blocked elevation, a policy applied overnight. Windows doesn't care who you are. It cares what groups you belong to. That's why technicians manage groups, not individuals. Group scales. Individuals create chaos. Here's the truth about command line. People don't hate it because it's hard. They hate it because it doesn't lie. GUI hides failure. Command line exposes it. When you run check disk sfc space /scan now or DiskPart, you're not clicking Windows. You're not clicking buttons. You're telling Windows, stop pretending everything is fine. Check yourself. And when Windows finds corruption, it tells you. No icons, no animation, just facts. If you're listening correctly, you notice something. None of this is about memorizing tools. It's about decision flow. What do I check first? Why that tool? What question am I trying to answer? You're not teaching what buttons do. You're narrating, thinking under pressure. Let me tell you exactly when people finally respect the command line. It's not during class. It's not during practice lab. It's when the GUI stops responding. Because here's the uncomfortable truth. The Windows GUI is optimistic. The command line is brutally honest. The GUI would spin up. It would freeze. It would say not responding like it's thinking about it. The command line doesn't pretend. If something's broken, it tells you. If something is corrupt, it tells you. If you don't have permission, it tells you. And that's why technicians trust it. Let's talk about sfc/scan now, but not the way students usually hear it. This is not a fix everything command. It's a verification command. When you run sfc system file checker, you're asking Windows one very specific question. Are your core system files exactly the way Windows expects them to be? That's it. If Windows says no integrity violations, that doesn't mean the system is perfect. It means the OS itself is structurally intact. That's huge, because now you stop blaming Windows and start looking at drivers, permissions, hardware, user behavior. Bad technicians keep reinstalling Windows. Good technicians narrow the scope. Now let's talk about check this, because this one gets misunderstood consistently. File systems errors don't announce themselves. They show up as program crashing sometimes, files that won't open, application freezing during saves, systems that boot slower and slower, and people blame RAM or the CPU or Windows being Windows. But the file system is just a map, and if the map is wrong, Windows gets lost. Check this /F doesn't magically make things better. It fixes inconsistency between what Windows thinks exists and what actually exists on a disk. That's why technicians run it before replacing hardware. because you don't replace an engine when the map is wrong. Now we need to talk about this part properly. This part is not scary. It's unforgiving. And those are not the same thing. This part assumes one thing. You know exactly which disk you're touching. There is no undo. There is no recycle bin. There is no are you sure? So technicians slow down here. They narrate every step out loud and even when alone. List disk, select disk 1, verify size, verify target, proceed. That's not paranoia. That's professionalism. Every disk disaster story starts with, I thought I was on the other disk. Let's fix one of the most confusing Windows problems once and for all. The user says, it says access denied. Everyone starts guessing. Bad technicians try a random fix. Good technicians ask one question. Who does Windows think you are right now? That's what who am I answers. Not who you think you are, not who you logged in as yesterday, but who you are in this moment. Windows permissions are evaluated in real time. Group membership, elevation states, token privileges. That's why something can work 1 minute and fail the next. And once you understand that, permissions stop feeling random. Up to now, we talked about everything about the lives inside machines. Now we have to step outside, and this is where students really struggle. Because networking problems feel invisible, but they're not. They're just layered. Here's the most important mindset shift in Windows networking. You don't ask, is the network broken? You ask, how far does connectivity go? Can you ping yourself, ping the gateway, reach local resources, resolve names, reach the internet? Each answer narrows the problem. I don't care how many times students hear this. It doesn't click until they see it. If you can access file shares, reach printers, ping local IPs, but websites won't load, that's not a cable problem. That's not a Wi-Fi problem. It's not a firewall problem. That is a name resolution problem. DNS translates human languages into IP address. No DNS equals no internet by name. And technicians check DNS first because it's fast and decisive. Students love IPs. They think it makes them advanced. Here's the reality. Static IPs are not wrong, but they're dangerous if undocumented. One wrong subnet, one wrong gateway, one typo in DNS, and suddenly local works, internet fails, nothing makes sense. DHCP reduces human error. That's why large networks rely on it. Technicians don't avoid static IPs. They respect them. Let me say this clearly. Turning off the firewall is not troubleshooting. It's destroying evidence. The Windows firewall blocks unexpected behaviors, unimproved traffic, and unknown apps. If something doesn't work, the firewall is telling you this doesn't match the rules. The fix is not disabling protection. The fix is understanding which app, which port, which profile. Private, public, domain, each one matters. Here's where students mix everything together. VPN, secure tunnel into another network. WWAN, cellular connectivity when no LAN exists. Proxy, control gateway for traffic inspection or caching. If you don't know which problem you're solving, you picked the wrong tool. Technicians never ask, what can I use? They ask, what problem am I solving? Real troubleshooting is slow. Not because the tools are slow, because thinking takes time. Windows problems are rarely one thing. They're a chain. They're a chain. A driver update, plus a permission change, plus a network profile switch, plus user behavior. If you rush, you may miss the link. And Windows keep reminding you, you didn't actually fix it. Before we finish this episode, I need to say something that separates junior techs from senior ones. Most Windows disasters don't happen because someone didn't know enough. They happen because someone did too much. They clicked too many things. They just tried something. They changed 3 variables at once and lost the ability to explain what fixed or broke the system. A real technician learns restraint. Sometimes the most professional move is, I'm not touching that yet. Let's walk through this the way it actually works. User says, my computer's slow. That sentence tells you almost nothing. So you don't react, you investigate. First question, slow doing what? Booting, opening apps, saving files, browsing the web? Because slow is not a problem, it's a symptom. Step 1, observation, not action. You log in, you don't open tools yet, you watch. Does the system hesitate when you click? Does the disk light stay solid? Does the fan ramp up? Already, Windows is telling you a story. Step 2, Task Manager, not to kill, but to understand. Most people open Task Manager to end tasks. Technicians open it to watch behavior. High disk usage, constant CPU spikes, memory creeping toward upward and never releasing. Now you know where to look. Not what to fix, but where to look. Step 3, Device Manager check. Now Device Manager makes sense. You're not hunting yellow triangles randomly. You're asking, is hardware behaving the way Disk Manager suggests? A failing disk controller, a bad USB device constantly reconnecting, a driver error repeating silently. This is how tools connect, not isolated sequentially. This is the most common help desk nightmare. User A, everything works. User B, nothing works. Same computer, same application, same network. People panic here, technicians don't. Step 1, identity check. Before you touch anything, who are you logged in as? Different user, different group, different elevation state? That's already 80% of the answer. Step 2, who am I in group membership? This is where who am I earns his place. Not because it's fancy, but because it removes guessing. You see group memberships, privilege levels, domain contexts. Now permissions stop being mysterious. Windows didn't break it. It followed the rules perfectly. Let's end the fear once and for all. User says the internet is down. Technicians here, connectivity stops somewhere. Step 1, how far does it go? Can you access local files? Ping the gateway. Reach an IP address like 8.8.8.8. If yes, congratulations, the internet is not down. Names are DNS again, every time. Someone always says, turn off the firewall. That's not troubleshooting, that's surrender. Firewall enforces rules. If traffic is blocked, it's because something doesn't match expectations. The technician question is, what rule is missing? Not, how do I get around security? Let me be clear about this. Reinstalling Windows is not a fix. It's a reset. Sometimes necessary, often lazy. When you reinstall without understanding, you don't learn. You don't prevent reoccurrence. You don't know what actually failed. Senior techs reinstall last, not first. If this episode felt long, that's intentional, because real troubleshooting is not fast. It's methodical. The exam tries to trick you into rushing. Real systems punish you for that. Windows rewards technicians who change one thing at a time, observe before acting, understand cause and effect, respect permissions, read logs, trust evidence over instincts. Once this clicks, Windows stops being frustrating. It becomes predictable. Drivers behave a certain way, permissions behave a certain way, networking behaves a certain way, storage behaves a certain way. And when something goes wrong, you don't panic. You ask, what rule is being enforced right now? All right, let's go to the questions. So how I do it is I read the question and then I give you the 4 choices. I read it again and then I give you the answer. Question 1. A technician disables a device in the device manager and the system immediately becomes stable. What conclusions can be drawn? A. The device hardware is permanently defected. B. The operating system files are corrupt. C. The device or its driver is contributing to the issue. Or D. The power supply is insufficient. A technician disables a device in device manager and the system becomes stable. What conclusions can be drawn? A. The device hardware is permanently defected. B. The operating systems are corrupted. C. The driver or the device is contributing to the issue. Or D. The power supply is insufficient. I'll give you 5 seconds. Think about it. 5, 4, 3, 2, 1. The answer is C. The device or its drivers contribute to the issue. Disabling removes the device from active participation. If stability returns, the device or its driver is the cause is linked, right? This doesn't automatically mean a failed hardware. It may mean a driver or resource conflict. Question 2. A user can access network printers and file shares but cannot open websites by name. Which configuration should be checked first? A. Default gateway. B. DNS server settings. C. Firewall profiles. Or D. Proxy configurations. I'll read it again. A user can access network printers and file shares but cannot open websites by name. Which configuration should be checked first? A. Default gateway. B. DNS server settings. C. Firewall profiles. Or D. Proxy configurations. Give you 5 seconds to think about it. 5, 4, 3, 2, 1. The answer is B. DNS server settings. Local resources access confirms IP connectivity. Failure to resolve website names indicates DNS failures, not routing or firewall issues. All right, we're halfway there. Hopefully you got them right. Question 3. Why should a technician avoid multiple configuration changes at once during troubleshooting? A. Increases system downtime. B. It complicates documentation. C. It prevents identifying the actual cause. Or D. It violates security best practice. Read it again. Why should a technician avoid making multiple configuration changes at once during troubleshooting? A. It increases system downtime. B. It complicates documentation. C. It prevents identifying the actual cause. Or D. It violates security best practice. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. The answer is C. Changing multiple variables removes cause and effect clarity. Technicians change one variable at a time to confirm causation. And the last question. Which statement best explains why command line tools are preferred during advanced troubleshooting? A. They bypass security restrictions. B. They perform faster system performance. C. They expose precise system feedback and errors. And D. They replace all GUI functionality. I'll read it again. Which statement best explains why command line tools are preferred during advanced troubleshooting? A. They bypass security restrictions. B. They provide faster system performance. C. They expose precise system feedback and errors. And D. They replace all GUI functionality. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And the answer is C. They expose precise system feedback and errors. Command line tools provide direct, unfiltered output that reveals system state, errors, and permissions without GUI abstraction. All right, let's bring it home, right, and wrap it up. Windows doesn't need luck. It needs logic. Every tool we talked about today exists because someone had to be observable. Device manager shows relationships. Disk management shows structure. Command line shows truth. Network tools show boundaries. Permissions show identity. Once you stop treating Windows like a black box, it becomes one of the most honest systems that you've ever worked on. So the next time someone says Windows is broken, you know better. Windows isn't broken. It's enforcing the rules. And now you know how to read them. It's not broken. It's geometric. Disk management cannot magically move space. Unallocated space must be adjacent. Not somewhere on the disk. Not technically free. Adjacent. If the layout is wrong, the option is grayed out. Windows is saying, I physically cannot do what you're asking. And instead of fighting the OS, technicians learn to read layouts. Let me say something controversial. Most Windows bugs are permission problems. A user said, it worked yesterday. That doesn't mean the system changed. It might mean they logged into a different account, group membership change, UAC blocked elevation, a policy applied overnight. Windows doesn't care who you are. It cares what groups you belong to. That's why technicians manage groups, not individuals. Group scales. Individuals create chaos. Here's the truth about command line. People don't hate it because it's hard. They hate it because it doesn't lie. GUI hides failure. Command line exposes it. When you run check disk sfc space / scan now or DiskPart, you're not clicking Windows. You're not clicking buttons. You're telling Windows, stop pretending everything is fine. Check yourself. And when Windows finds corruption, it tells you. No icons, no animation, just facts. If you're listening correctly, you notice something. None of this is about memorizing tools. It's about decision flow. What do I check first? Why that tool? What question am I trying to answer? That's what makes this episode engaging. You're not teaching what buttons do, you're narrating thinking under pressure. And that's all for today. And this is Professor J Rod, who always reminding you, thank you for listening and keep tapping into technology. This has been a presentation of Little Cha-Cha Productions, art by Sarah, music by Joe Kim. We're now part of the Pod Match Network. You can follow me at TikTok at Professor J Rod, that's JROD, or you can email me at ProfessorJRod, JROD, @gmail.com.